Certain transformations we're not going to do with exponential functions, and this is just explaining why. So the first one we won't do is vertical expansion. So a vertical expansion would just be some number times whatever we're doing. So for instance, it could be y equals 4 times 2 to the power of x. Well, 4 can be written as 2 squared to the power of x, and since the bases are the same, you just add the exponents. So this is the same as 2 to the power of x plus 2. So this vertical expansion by a factor of 4 is equivalent to moving this function 2 to the left. So this is true for absolutely any vertical expansion or compression can be represented by a horizontal translation either to the left or to the right. So because of that, we won't do any vertical expansions in this section because we can always just translate it horizontally. We will also not do any horizontal expansions or compressions. So for example, 2 to the power of 3x is a horizontal compression by a factor of a third, but it's also the same as 2 to the power of 3 to the power of x, because 3 times x is 3x, which is like 8 to the power of x. So absolutely any horizontal expansion or compression can be taken care of just by changing the base. So we're not going to deal with any horizontal expansions for this reason. And lastly, as we saw in the first example, reflections in the x-axis are really just a reciprocal on the base. So it's the same thing. Because it's up there, it's -1 times x. We can separate it, and then it's just half to the power of x. So we already saw that the other time. So we're never going to do any reflections in the y-axis, horizontal expansions or compressions, or vertical expansions or compressions in this unit.